2.2, displaying and describing data. And describing data is going to be the focus on this. When you look at a graph, we're going to look at two new graphs today in this lesson, but pretty much any graph. This little checklist I'm going to give you, this is what you should be thinking about. Can you determine these characteristics of our distribution? And that's what you should be trying to show to the public or in your display when you are describing what we see. So center is the first thing. Where does the sample tend to fall? This is we looked at when we were comparing dot plots. We saw just where were the dots, which data set had higher dots, lower dots, and we could see where do they tend to fall. So the first thing is going to be the center. Looking at your graph, can you describe and pick out where the center is? The spread or variability of it. This is not seen. Do we have a consistent graph or data set, or do we have an inconsistent graph depending on how far apart they are? Okay? So these are the two, in my opinion, I think these are the two main things that you're going to have to be able to pick out. Okay? We also have shape. Okay? So now we know where our center is, we know where our points tend to fall. Now you're going to look at it and say, is there shape to it? Okay? So we have a couple different here. We have skewed to the right, skewed to the left, and we also have our symmetric shape here. Okay? This is considered the normal curve. We'll look at that a lot more throughout the year if we have a symmetric data set and what we can do with it. When we have it skewed to the right or left, that usually means there's some points that don't exactly fit the pattern, that maybe stick out a little bit. And you can see that the point or the peak is up high, and then there's a flatter side where those extra points would be. Remember these density curves, they're tracing a graph. So you would have maybe a bar graph or a dot plot here, and this is kind of tracing it. And the reason it's flat here is because there's some extra points that stick out. For the direction of skewness, you can't just say it's skewed, you don't have to give me direction. The flat side is the direction of the skewness. So we had flat on the right-hand side, so this was skewed to the right. Over here, it's flat on the left-hand side, it's skewed to the left. Now we also have symmetric with two peaks. We're not going to look at too many multi-mode data sets in this course, but just so you can see, if there is a graph that goes up and down multiple times, you can see that there's multiple peaks or multiple modes. Okay? But the three we're not focused on: skewed to the right, skewed to the left, and symmetric. And for the skewed, you're going to have to give me directions. And here's just one thing I saw that maybe helps a little bit. If you look at your feet, if you trace your toes, that's the direction of the skewness there. So if you look at your left foot and you would trace that, there's our peak, and then it's flat on the left-hand side. That's your left foot. That might help you remember that that's skewed to the left. Opposite going to the right, there's your peak. The flat is on the right-hand side where your little toes are, so that's skewed to the right. So I just hope maybe that might help a little bit when you decide, is it left skewed or right skewed, knowing that it's not symmetric. So we have center, we have spread, we have shape. Also have to describe the outliers. Outliers, a score that does not fit the pattern. So a lot of times this is on a make the skewness if there's a couple points that don't fit the pattern a little bit. So outliers are just points that aren't exactly in with everyone else. Not good, not bad, but there's something that should be investigated. Maybe if the method didn't work out right, how you were collecting the data, or maybe that data set just is an interesting data point and you should do more investigating why they were really high or really low depending on where the outlier was. So here's our checklist: center, spread, shape, and outliers. Now this is what you're going to need for definitely the two graphs that we cover in this section, but there's also going to be some other graphs that you could do this with. If you look at a box and whisker plot, okay, you can see the spread, you can see the center. These are things that you should be able to pick out in almost any quantitative data set. You're going to have to make sure you can find those, okay, and describe what we see in those. Now the first graph we're going to look at is a stem and leaf plot. Now what a stem and leaf plot does, you look at it like it is a histogram, which we'll talk about a little later, or a dot plot. The numbers are going to be lining up as our dots. So as we looked at our dot plot where we stacked up those dots, that's exactly what a stem and leaf plot's going to do. We can see where do these numbers stack up. It's not just going to be an individual number though, it's going to be a little bit of an interval. So it has to be quantitative data, And the important part here is we're separating each data value into two pieces, okay? So one piece is going to be the stem, one piece is going to be the leaf. Now, a lot of times when you look at it, people automatically want to cut the number in half. It's not always going to be as simple as just cutting the number in half, okay? So you really have to look and decide where is the best place to cut my data. And when you do some of the assignments, you'll see where good places are, where bad places are to cut them up, okay? So here's our data set. Okay, we have, this is on me, I didn't have room for a title here. These are the rulers of England, and we have how many years they were in charge, how long their reign was. So you can see, we have someone at 0 years, then we have a couple people, 56, 38, 44 over there, 59, 63 over there. So some of them were there for a long time. What we're gonna do is put together a stem and leaf plot with these data points, okay? So since these are two-digit numbers, or at least the majority are two-digit numbers, it is kind of obvious where we should split it up at, okay? You should split it up between the tens and ones values, and what it's gonna look like is this, okay? Ignore this, I got this picture from our textbook, okay? But here is our stem, and here is our leaf. Now what this is missing right now is a key, and a key is important. The keys, I'll show you how we actually put these numbers together. Because you might not see that, the data set like I just sat in that table, so you might not know what it is. What the key would show is, what does the stem and the leaf represent when you put them together? So you should just pick any combination here, like I might pick 3, 5. 3-5, and that equals 35 years. So now I know, okay, 3, 5 is 35 years. That 4 and 4 is 44 years. We add some single digit numbers. 0, 1 is 1 year, 0, 2, even 0, 0 is 0 years. Okay? And what you can see here is that numbers do repeat. So like there was 1, 3 is 13. There were 4 people who were in power for 13 years. Okay? So you can see mode. You can see where how many years they were. For 22, there were 3 people at 22. Now thinking about the shape, okay? Now those density curves we saw for shape, they were drawn, and you kind of have to imagine if I took this and flipped it sideways, what would it look like? Okay, well if I did trace these, okay, there's my density curve. So it does go a little flat down here. Okay, we have a lot of points that are at 12, 13, 15, but here's our shape. We have a couple points down here, just a few of the higher years. Okay, so if I was describing this data set, okay, center, the center is where you're going to estimate where the middle would be. That'd be somewhere right around here. Like, I'm not even saying a number right now, I'm just using my hand. Right there's the majority of our points. So I would say the center is between maybe 10 and 22. Okay, maybe when you get a little more narrow, maybe 13 and 22 years. Okay, so for the center, you can give me a range. Center, we said 13 to 22 years. For the spread, I usually just pick out the low and the high. We have someone who's at 0 years. Spread, 0 years. 2 going down here to 63 years. Okay. The shape, we have our peak. Again, if this was flipped sideways, our flat side would be on the right. So we have it skewed to the right. And I don't see any outliers. If you don't see any gaps between intervals, I'm going to say there's no outliers there. Okay? So here's an example of a stem leaf plot and the description I'm going to want. Center, spread, shape, and outliers. And again, if you see no outliers, you can say no outliers in this case. Now, back-to-back stem and leaf plot. Okay. 2 data sets with a common stem. This is if you're looking at 2 data sets that you want to compare. Kind of like when we did dot plots. We had them stacked on top of each other. A back-to-back stem and leaf plot is on the common data set. So here we have block 1, block 2. We're looking at grades. Okay, so grades are in percent here. So here's, let's just say this is 2 of my classes. It should be common as in like the units are the same, so we are looking at the same type of data here. And if I was to make the back-to-back stem and leaf plot, this is what we would have. Okay, so we have block 1, block 4, so it's nice and labeled, percents, and there's our key. 7-3 is 73%. You only need one key, because now you know this is our stem, and we have leaves for both of our data points here. So we know if we have a 7-3, that's 73%. So we have some 60s here, 70, 74, 74 repeats. Going the other way, we know this is our stem. This is on be our leading digit, 80, 90, 91, 92, 94. Okay, and again, we can see now and compare, okay, who tends to have the higher score? Well, the center here is in the 80s. The center might be a little lower in block 4. Okay, the spread, block 4 is a little more spread out. They go from 60 to 96. For the block 1 only goes from 70 to 98, so it's a little more consistent. When there's this few data points, intervals, sometimes the shape can be a little hard, so don't get overly concerned about picking out the shape, especially when you have small data point set of intervals like this. And when it comes to outliers, I don't see any. Okay, I don't see any outliers because there's no gap in between. So this is a back-to-back stem and leaf plot. Okay, so it is good if they are, again, it was the same information. We had grades for both in percentages, so a back-to-back stem and leaf plot worked out nice. Okay, so that's stem and leaf plot. You should go practice, look up a little more information on stem and leaf plots, and then we're going to move on to histograms.